All right, guys, so today we're going over the review sheet to get you ready for the test. Tomorrow. Test is tomorrow and Friday. Both parts.
I'm going to be here tomorrow, and I don't know if I'm going to be here Friday.
Okay. Okay, so we'll have you make it up later. Now, each part's only 10 questions. So you'll have that class period to do each part, and that's going to be it, because you will definitely have more than enough time to factor 10 problems in 50 minutes. So, again, now there's not going to be one quite like A. There are 3 on the test that are just greatest common factor. You pull it out. But both of those, what's left inside the parentheses is going to be 2 terms. So they're not going to have 3 like this here, where the only greatest common factor is AB squared. We have 3 terms left over. Yeah. So, door, yes. So the only thing we can factor out of this first one is AB squared. The 6 stays put. Now, since we're taking an A out of A cubed, we're left with A squared. We removed 1A from A to the third, so we have 2 of them left. Now the B squared factors out completely, minus 36. A factors out completely, B squared factors out completely, so the middle term we're just left with is 36 plus 71. Now our A squared, we're factoring 1A out of A squared, so it returns it to A. B squared factors out completely. And that's all we can do, because 6A squared minus 36 plus 71A, even if we got it back into standard form, is not factorable. Now, let's look at problem number 2. If we have 2 terms, especially on this test, it's going to be one of 2 things. It's either going to be a difference of perfect squares or sum or difference of 2 cubes. So if we look at this here, 36x squared minus 49b squared, well, the x squared and b squared kind of give us a hint that it's not sum or difference of 2 cubes, because that's to the second power, not the third. So the only other thing we need to check and see is, are these 2 terms perfect squares? Because 36, what times itself is 36? 6, what times itself is x squared would be? X, and then 49 would be 7 in B. So 36x squared minus 49b squared, so we would get our first term, 6x, plus our second term, 7b, times 6x minus 7b. Because our sum, or our difference of perfect squares, the general form is our a squared minus b squared is equal to a plus b times a minus b. So really, you could follow that there. A is 6x, b is 7b. Replace a and b and simplify where needed.
Are you going to have the formulas written down somewhere tomorrow?
I'll leave those up there, yes. Questions on number 2? We feel good about number 2. Let's look at number 2. So here, we have 3 terms, so we'll do our normal factoring. First step, and really with all of them, is there a greatest common factor between these 3 terms? Is there a number variable that will go into all 3? Well, here, no. So we'll do our 2 sets of parentheses with 3 spaces. Our next step is to find the sign. If the third term is positive, matches the signs of the middle term. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. So since the third term is positive, the signs are the same and match the sign of the middle term. So plus and plus. Our next step is to find the factors of the first and third term. So for 4x squared, we will have x and x. 4 is 1 and 4, 2 and 2. So here we can try 2 and 2. Factors of the third term, 9, 1 and 9, or 3 and 3. And we can try this here. We really need to pick just one of the factors of 4, one of the factors of 9, plug them in, because our last step after we plug them in is to check to see if we get the middle term. 2x times 3 is 6x. 3 times 2x is positive 6x. And 6x plus 6x gives us positive 12x. Questions on number 2? And if we don't get the correct middle term, we could change either the 2 and 2 with our first terms, the 1 and 4, or switch the 3 and 3 to 1 and 9 and try again. Questions? All right. Yes. Huh? Are there questions on 3? Yeah. No. Let's look at number 4. Is there a greatest common factor between these 3 terms? X squared, 6x, and 27. No. So we'll have our 2 sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite. Now we need to find the factors of the first and third term.
First, so really is just x and x.
X and x.
Minus 27, so it's like what, 9 and 3?
3 and 9. 1 and 27, 3 and 9. Which one do we want to try first?
3 and 9. Definitely 3 and 9.
Check. Yes. So x times negative 9 would be negative 9x. 3 times x is plus 3x, giving us negative 6x. Now, since we got the correct number but wrong sign, we need to flip the signs. If we get the correct number but wrong signs, flip the signs. But again, on all these here, even if you get stuck on one of them, get the greatest common factor out, finding that does give you some of the points. Here, getting it set up and then getting the correct sign, one positive, one negative, gets you points. Getting the correct factors for x squared. So, again, getting it set up and doing as much as you can, even if you get stuck, will help. Questions on how we factor number 4, how we do this here? Questions on 6?
Isn't that just the...
Difference of perfect squares, yes. So do we need to see how to do that one, or we feel good with that one there? So what's, yes, it's again following us, our a squared minus b squared. A plus b times a minus b. So there is no greatest common factor between the two. What times itself is 64x squared? Would be 8x. What times itself is 1. So a in our case is 8x. B is 1. So a plus b, so that would be 8x plus 1. And a minus b would be 8x minus 1. So all we did was replace a and b with 8x and 1. Let's look at number 7. A cubed plus 1. So we have a to the third power, yes? So there's a good chance it's a sum or difference of 2 cubes. There is no greatest common factor. So the main way we would know is it possible, or is there an expression that multiplied by itself 3 times that gives us a to the third? A. Because we can take the cubed root of a to the third and get a. And we can also take the cubed root of 1, which is 1. Okay? Now, again, we can simplify kind of like what we did here. General form of sum of two cubes. A cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. Well, what's our a term here? Well, it is actually just a. What's b? So it's a plus 1. We replace a with a, b with 1. The next one, bless you. Our a is being replaced with a again, so we have a squared plus a times b plus b. So all I did is go and replace the a with its a term, which incidentally is just a, and replace all the b's with 1. Almost. Because we just need to simplify a little bit. A plus 1 is simplified. A, the quantity a being squared is just a times a, which is a squared, minus a times 1. 1a or 1 plus 1 squared, which is 1. Because the terms were a and 1, not a whole lot happened, but let's look at 8. 8, well, because we'll come back to these cubes here in a second. Okay, let's look at 8 next. 8x squared minus 72. We have two terms, we have x squared, yes? Subtraction, so there's a good chance it's a difference of two squares. What times itself is 8? Another way we could is check if we can take the square root of 8. Is there a square root of 8? 2 squared root of 2. Okay. Let's look back at this. Is there a number that goes into 8 and 72? What's 72 divided by 8?
I did it. For the first time. I'm not needed. I'm right.
So the greatest crowding factor is 8. So when we factor it out, we do get x squared minus 9. Well, what times itself is x squared? Well, x. What times itself is 9? 3. So our a and b terms, a is x, b is 3. So our a plus b becomes x plus 3. A minus b is x. So really with the difference of two squares, find a and b, plug them in. And if you're not sure if they are a perfect square, take square root. It'll tell you if they are or not. 10 or yeah.
Like the x plus 3 and x minus 3. How is that a simplified version of x squared minus 9?
So this here can simplify because x plus 3 times x minus 3 are actually the factors of it. Combined like terms, yes. So here with factoring, we're wanting to decrease the power attached to x, to the variable. So since here it's x squared, we're wanting to get it down to 1 or as close to it as we can. Because 10, we don't have a sum of two, or a sum of perfect squares. There's not going to be one like that on the test. It is going to factor. Every problem on the test is either going to factor with the greatest common factor and end up with a number and two terms inside, or two sets of parentheses. they will simplify down. You won't have one that's not factorable.
There just won't be questions. Just not.
Yeah. Factor, yes.
Good, because when they're not factorable, I just kind of look at them like I'm stupid. Like there's something I'm doing something wrong.
That's why I don't like putting those on the test, because your first thought is not it's not factorable. It's more I'm doing something wrong.
Now I got to factor it.
So look for greatest common factor first, and then at least a greatest common factor will come out. All right. So, yeah. Let's look at 13. Number 13. So these two numbers, we have a cubed, b cubed. When those variables are cubed, there's a good chance it's a difference or sum of perfect cubes. The only thing you need to check and make sure there's no greatest common factor, especially with the variables. A and B are not the same, so we can look at 375. Now we can take the cube root of it. 375 is, so it's not a perfect cube, but there might be a number that goes into both. And with all these here, we'll start with lower numbers, so 2, does 2 go into both? How about 3? Well, we can try 3. 375 divided by 3. 192 divided by 3. So let's check those cube roots. 125 is 5. Cube root of 64 is 4. So square root of 64 would be 8, yes. So that tells us, well, there's a greatest common factor of 3. So we'll pull it out first. Now we need to find our A and B. So as we found already, the cube root of 125 is 5. The cube root of 64 is 4. And our A cubed, B cubed would be A and B. And again, I'm just writing above it the general form. This is the general form for sum of two cubes. So let's look at the first set of parentheses in the general form. It's A plus B, yes? So what took the place of A? Well, A cubed is here, yes? So the A is 5A, so we'd have 5A. Plus our B is, incidentally, 4B. The fact that A matches up with A, B matches up with B is more coincidental than anything else. Does that make sense how we got the first spot? And the bigger our first term is, A squared. So we take 5A and we're going to square both of them. Minus, we have A, and then we actually have B. So we'd have 5A and times 4B. Plus our B squared. So A in this case was 5A, B was 4B. So we have those there for now because we're going to simplify it, because our first term, our A being squared, is 5A times 5A. 5 squared is 25, A squared is A squared, because we're squaring that first term, which is 5A squared. So we get 25A squared. In the middle, the 5A times 4B, 5 times 4 is 20, AB. Plus our B squared, our 4B squared. 4 squared is 16, B squared is B squared. So I would put the extra parentheses just so we can bring it down one to the next. So really from here to here, we're using the general form and just sticking the values for A and B in each of the spots. Then that next part is just simplifying each of those. And really the bigger set of parentheses is the only one that needs simplifying. While we're doing this here, let's look at 14. 729x cubed minus 8. No greatest common factor that it looks like x cubed is going to be our key indicator that there's a good chance that this is a difference of two cubes. X cubed, tell me x cubed, so if it's factoring, it's going to factor, it's probably going to be a cube. Now the question is there a cubed root of 729? Nine. See if there's a cubed root of 8. 2. Since there is no greatest common factor, we're trying to find our A term. So the cubed root of 729x cubed. Well, 729 is 9. And the cubed root of x cubed is x. So that tells us the number that's taking the place of A is 9x. Cubed root of 8 is 2. So our A term is 9x, our B term is 2. So looking at the factors form, our first thing is A minus B. Well, what's A? 9x. What's B? 2. So the first set of parentheses is 9x minus 2. Parentheses. A is being squared, so we have squared plus A, 9x, B, 2. So we're going to multiply those two together, plus B squared. Now the first set of parentheses, the 9x stays the same, minus 2 stays the same. 9x squared. 9 times 9? 81x squared. We're doing 9x times 9x. So 9 times 9 gives us 81. X times x gives us x squared. Plus 9x times 2. 9 times 2 is 18x. Plus 2 squared. 2 times 2. 4. Because we did go over ways to memorize the signs and go through this here, but if we want to simplify it down, it's just finding, okay, this is our A term, so we're going to plug it in here, here, and here for A. And this is our B, and we'll plug it into its corresponding 3 spots. And that's worked for the same of sum of 2 cubes. Sum and difference. We find A and B and plug them into their corresponding spots. Are we going? Yeah. We're going over the review sheet to test tomorrow. You feel ready for this tomorrow? Ready? Okay. Yeah. Okay. Questions on 14. Do we feel a little better about the sum or difference of 2 cubes? Okay. Any other questions on 8 through 16, or 8 through 18? Any one of those on there that y'all want to look at?
Is there gonna be one like 11?
Yeah, I was gonna ask.
So 11, not quite, because 11, there is a greatest common factor, of 7. So 49, 343, and 7 do have a common factor of 7. And they also have a greatest common factor of x squared. And if we factor 7 out of 49, we're left with 7. If we factor an x squared out of x to the 4th, we're left with x squared. Plus, if we factor 7 out of 343, we're left with 49. And we factor an x out of x squared, we're left with x. Plus 1. This doesn't factor any further. So if there's going to be one like 11, what's going to end up being left would be like 7x squared times this here. So the ones that do have a greatest common factor only, you end up, what's inside the parentheses is just 2 terms. We can check for difference of 2 cubed or difference of perfect squares. It's not a difference because it has to be minus. There is no sum of 2 squares. Also, 7's not a perfect square or perfect cube. That would be as far as it would go. Does that make sense? But we can see more like the ones on the test. There will be later in the packet. So do we feel any others on 8 through 18 that y'all want to look at? (19 through 22). Not, I'll look at 21. Is there a greatest common factor between these 3 terms for 21? 5. 45, 150, and 125 do have a greatest common factor of. And what else? So the first one's number would be 9. There is another greatest common factor between these 3 terms. So, why? Just why? Because
you need to go to the library.
All 3 do have a common factor of y. That's how it works out. Since they all share that y, we have to factor it out to make this work. So 9x squared, and the y factors out completely, because we take 5 from 45 and get 9. We take away the y, we're left with this here. So if we factor 5 out of 15, we're left with 3, yes? So out of 150, we're left with 30x, and the y factors out completely. Plus 125 would indeed be 25, and the y factors out completely. Two sets parentheses with 3 spaces. Third term is positive, so the signs are the same, and that's the sign of the middle term. So we have negative and negative. Factors of the first and third term. Factor of the first term is 9x squared. So 3x. 5 and 5, yeah, because 9 is 1 and 9, 3 and 3, 25, 1 and 25, 5 and 5. And we can check this here and make sure. 3x times negative 5 is negative x. Negative 5 times 3x is negative 15x. Because having the work there is nice, especially on the test to look back at to try to see your work. And there's, yeah, that's fine. So how do we feel about sum or difference of two cubes and our normal factoring difference of perfect squares? We feel pretty good with those? We can come back to 22 if we want. Let's look at 27. So here we do have two terms. Now, the reason I would know 27 is not a difference of two cubes is because, well, one of them we do have x cubed, the other we have x squared. They both would have to be cubes. So 12x squared is in common with both. If I factor the 12 out of 12, it reduces completely. When I factor x squared out of x to the third, we're left with x minus. When I factor 12 out of 144, it reduces the 12. The x squared reduces completely. So this here is like one of the ones that would be on the test with just greatest common factor. Almost. 15x. So the 15x, when factored out 15x squared, we're left with x.
Yeah, because that really pinpoints down the character or like half of a big chunk of those names.
This here, I'm just picking another random one for greatest common factor. So if we look at these two here, is there a greatest common factor between these two terms? We would have x, and 21 and 14 would have a greatest common factor of 7. So if I factor the 7 out of 21, we get 3. X out of x cubed is x. Y squared stays there. 7 out of 14 is 2, and the x factors out completely. Now here we do have x squared, y squared, plus 2. And again, there are some like this here where we'll factor out to have two terms. We don't have a sum of sum of perfect squares. Also is 3 a perfect square. Now 3 is prime, 2 is prime. So there might be one like that, but most of them we factor out will have two terms left. That makes sense? So questions on any of this so far? We feel a little better with factoring? Feel a little better for this test? 10 problems shouldn't be too bad. 2 parts. And again, when I'm grading for all the parts. So even if you get stuck, get what you are sure of for the factors and then go from there. This because there are points for having the correct signs, correct factors of the first term, correct factors of the second term. Doing that there. Let's look at this last one. X to the fourth minus 32x squared plus 256. This here, this type of problem is one of the extra ones. Now, since there is no greatest common factor between these three terms, we can move on to our 2 sets of parentheses with 3 spaces. Now, since the third term is positive, the signs are the same and match the sign of the middle term. And negative. Now, x to the fourth, or what times itself is x to the fourth, is x squared and x squared. Now, 256 is 1 and 256, 2 and 128. 6, 5, or 7. 13, 3 is not a factor, but 4 and
Okay, that's
4 and 64. Yeah,
Just the 100.
24. Yeah.
Yeah, because the 100 happens to be your 20
This, yes. 5 doesn't work because it doesn't end in 0, 5. 6 doesn't work because both 2 and 3 didn't. 256 divided by 7 doesn't work. 256 divided by 8 and 32. 256 is not going to divide by 9. 256 does not divide by 10. 256 divided by 11. Yes. Yes. 6 divided by 16. We can check and make sure x squared times negative 16 is negative 16x squared. Negative 16 times x squared is negative 16x squared. Giving us negative 32x squared, yes? Since we do have x squared here, x squared minus 16. Is x squared a perfect square? X and x. Is 16 a perfect square? So that means this first one is a difference of perfect squares. It'd be x plus 4 times x minus 4, yes? Wait a minute. The other one is the same thing, yes? So it also would be a difference of perfect squares. So we could take it we could do them individually squared. It's a little convoluted to do, you know. I mean, you could. Yeah. We don't normally do the parentheses squares. But, so that's everything that's going to be on the test. So the ones we didn't cover, go on and go back over them just as extra practice. If you do have questions, please